I'm Stephen Foskett, the organizer of Tech Field Day, and we're here in Austin, Texas for Tech Field Day 13. I'm joined today by Robin Systems and a group of invited delegates from around the world. They are to ask questions and participate in the discussion. If you'd like to learn more about what we're doing, go to techfieldday.com, and you can find more videos like this at youtube.com/techfieldday.
All right, so I'll spend a few minutes talking about the performance of our solution. I mean, clearly, as you can see, we are targeting databases and any data-heavy application where performance is very sensitive, right? So first, I'm going to talk about the ezFIO benchmark. ezFIO is a wrapper around the FIO, standard FIO benchmark. As you can see, I'll not go through each and every number. There's a lot of numbers out here. We are about 97%. Actually, let me explain the context of this thing. So what we did is we ran ezFIO on bare metal machine, right? And we got the numbers. Then we ran the same test running within the Robin container on Robin storage. So the bare metal, of course, is writing to the raw disk. This is running through Robin attached storage or Robin managed storage, which has snapshotting and all of that capabilities, right? Yet we are able to do about almost close to bare metal performance. 97% of what you're getting with bare metal, we are getting with Robin. And about 92% of write we are getting with Robin. Now bear in mind that when you're writing to the raw disk, you're actually overriding blocks and whatnot. With Robin, because we allow you to do continuously snapshot your data, right? We also incur that additional cost. Even with all that additional cost, we are pretty much close to where bare metal performance is. Now that is a synthetic benchmark using FIO. So the next thing we did is we ran a application benchmark. So we ran YCSB on Cassandra. And what we wanted to do is, we wanted to compare where we are with bare metal, obviously. But we also wanted to see if you were to run the same Cassandra cluster within a virtual machine, what kind of performance you see, right? So this is a 3-node Cassandra cluster with 3-way replication. So Cassandra is doing the data replication, and we ingested about 1 billion records, right? So YCSB, those of you who are familiar with it, has about 6 tests or so, which is a mix of reads and writes and more writes, more that kind of stuff. And so this is the bare metal numbers. Now, compared to bare metal, this is where Robin is. Again, very, very, very close to where the bare metal numbers are. You get the performance along with all the other features that we talked about. Now, we ran the exact same test on the same hardware using a virtual machine. And this is where the virtual machine is, right? So that is with a modern day distributed application as the performance that you get. What about Hadoop? So with Hadoop, we ran the standard TeraGen, TeraSort, and TeraValidate, the terabyte of data. And again, we are pretty close to where we are with bare metal performance. Okay, so the next test is, remember I told you that one of the common problems that our customers face is you have your Cassandra or any application running, they're putting it on bare metal because as you notice, the moment they put it on a virtual machine, they get about a 40-60% performance hit, right? That's why they put it on a bare metal, but that bare metal is underutilized, right? So we have heard utilization numbers like 20%. It's as bad as that sometimes, right? So we said, okay, how about this? Let's take a 3-node cluster, a 3 nodes, put Robin on that, and then bring up a 3-partition Cassandra application, get one application, right? And measure how many IOPS it gets and what is the latency and so on. So this is with that. So 3 nodes with the 3-partition 1 application Cassandra running, or 100,000 ops with 1.1 millisecond latency. Now we said, okay, let's put another application along with the same one and measure it again. So we see 2 Cassandras running per node, 2 Cassandra instances running per node, and you get about 96,000 ops with 1.25, barely noticeable increase in latency, right? Then we said, okay, let's put another one, third one, and then you get about 90,000 with again barely noticeable latency impact. Now the thing is, of course, why is it not 3 times 100,000? It's because we are pretty much hitting the max of the resources that the physical hardware itself provides, right? If you have to configure the hardware with a slightly larger amount of memory or CPUs, then you should be able to get 3 times what you would get with a 1-node Cassandra cluster. So again, we are allowing you to consolidate your data-heavy applications. We are allowing you to do push-button lifecycle management of any application, single workflow with push-button capabilities. And we allow you to do QoS control so that you can ensure that your applications are performing the way you want it to. With that, conclude. Thank you. Yeah, any questions?
So you talked a lot about database applications and a lot of benchmarking on the database applications. Have you guys has your company looked at, or are you looking at expand any other use cases outside of the database applications?
I mean, clearly we can and we do support any stateless application also, right? The reason I didn't bring it up here is because when stateless application, there's not a lot of life cycle management you do, right? There's not a lot of data that you have to preserve where performance or QoS matters, right? But clearly because it runs unmodified Docker containers, unmodified LXC containers, anything that you would put on a Kubernetes platform, for example, which would normally be your microservices app, would perfectly run on this platform.
The way I would qualify this is more a... Can you turn your mic on, sir? The way I would qualify that is that this is more a go-to-market decision on what are the applications we focus on as a startup so that we get the maximum ROI just in terms of the POCs and engagements. Ultimately, given that we support LXC, anything that runs on Linux, you can run on a Robin platform. And as we expand and sort of scale out, I expect it will pick up more and more of the legacy applications and other things. But our initial focus is big data and databases because that's where sort of data and performance come together.
Seems to be an appropriate focus. I'm not challenging your decision, by the way, just asking the question. Yeah, I think you made it's impressive.
So I saw the fault domains and the replication if you have a local failure. How do you handle exporting your data out, backing up, essentially? What mechanisms do you have for that, and how can I ship my Robin cluster off to another data center or cloud or whatever?
Okay, so there are two parts of the question you're asking. Number one is, how do you export the data? The other one is, how do you do DR?
Yeah, so backups is basically the...
So like Deva was showing you in the demos, right? Each container gets its own IP address. So in a way, to an external world, it looks like a virtual machine, right? So you would use the same set of tools that you would use today, let's say an RMAN for Oracle and so on, to go pull the data out, and then do whatever workflow you have to back it up. DR is tricky because there is, of course, external DR that you could do. That is something that we want to engage with other partners. But in our roadmap, we actually want to provide DR as a native functionality of the product itself. We don't have that today, right now, but that is something that is going to come very quickly. And that will allow you to spin up clusters, whether it is in the public cloud or on-prem or within two different data centers on-prem and so on.
So would you recommend to like the YAML files have a manual backup somewhere of those, or can you export all those configurations?
Well, absolutely, yes.
Okay.
Question?
You can have the configuration back. Yeah, go ahead.
Sorry, didn't mean to interrupt you.
No problem. Go ahead.
So taking your YAML files as input to the system, which basically provides the desired state for your application stacks inside there. Are you, have any of your customers done this already, or have you done this internally? Are you tracking or pointing to a Git or GitHub repository, some sort of source control repository where I have a governance model for who can approve a change? Is that change tested? Is it going to be into my CI system? Does your system pull from those already as it is, or do you provide hooks so that we can push configuration changes?
Internally, we do have a Git repository where we have all the YAML files, all the bundles. But regarding the customer-specific configuration, right?
Can I ask for clarification?
Yeah.
I don't think I heard a clear answer to my question.
Okay.
I'm hard of hearing, so I may have misheard it. Let me restate. Can you point your system to an existing Git repository so when I change a file in that Git repository that it will notice that there is a change and pull that down into production into your system?
The bundle or
the YAML file that describes the bundle, the source control, the source.
No, we don't have an automatic way to pull
okay, thank
the
you.
YAML file.
Do you have, on the flip side, do you expose an API or do you provide an SDK so in the CI systems that are everywhere, that part of the release into production of the change of that file releases that into the production state of your system?
Yes, that we do.
Thank you.
And a related question, so the payload containers that are being deployed out, how do you handle updates to the images? So I've got a newly released, an updated Docker image.
Right, so that's what I was asking, right? If it's the YAML file or the container. So let's say you have a CI/CD pipeline where you're building the container itself. So in the YAML file, if you notice, when you specify that for this role, I want to use this image with that version and which Docker registry you want to pull it from, that could point to a private Docker registry which you're updating periodically. And the label that you can give here is latest. So when you spin up a new cluster, it's going to go pull the latest Docker image for that particular application. So that's how you would keep it in sync.
Well, that doesn't keep you in sync because that instantiates on whatever's latest at the point that you stand up the cluster. What happens when I push version?
So that is a very tricky thing with Docker, but with LXC it is very straightforward, right? Because LXC is almost like gives you a virtual machine like a feel. So if you want to push changes to an LXC container, then you would normally, however you would do it, right? You just go ahead and do that. Maybe if you're doing yum update, right? That's what you would do. But for Docker, you actually have to create a completely different image, right?
Oh yeah, but other solutions that allow me to lifecycle a collection of Docker instances allow me to say, I want to do a rolling upgrade to the latest now, please.
Yes, you can do that, as I said, with the tag.
And
So you have a running application, if I understand it. You have a running application, the container image has changed.
yeah.
So you can bring this down, and then when you bring it up, it'll pull the latest image.
But I can't do a timed evacuate. So the population across the old and the new deploy remains at 20 instances. And as one instance of the new is stood up, that one instance of the old, the way you're describing is I have to tear down the entire 20 instances, have no service, and then start again.
Well,
although I guess you could
you're
bring
right.
the
If
whole
you have
20 new up.
two images, one running, sharing the same image, yes, you'll have to take both of them down on a per machine basis. So you can do it on a node by node, physical node by node basis. Right?
And I believe you covered this, but I want to clarify. One, do you respect the anti-affinity rules that can be defined in your containers?
Absolutely, yes.
And then you said you can go node by node and say upgrade this node, upgrade the other nodes. So I'm interpreting that, and have any customers use that, or you and your labs use that as a way
So we have a Hadoop
phase rollout?
Yes, we have a Hadoop customer who does anti-affinity, and then